That's too kind, really. Thanks, Jeroen. This. I can really recommend that movie. I had to test the sound somehow. Right. So, thank you all for being here. Good evening. My name is Vincent, and I'm a poet, or at least I presume you will all think so with this wonderful title I came up. A glint of a stint with ESLint. I really think maybe I should be a rapper. I can do like glint of. Anyway, so for tonight I'll be discussing some of the background and the role that linters play in the JavaScript ecosystem, and how TypeScript is basically the next step after that, and also how that's a good way of looking. I hope to make clear why that's a good way of looking at TypeScript. And so basically we'll be taking a look at the ecosystem of static analysis in JavaScript. And so before I start, I'd like to start with a question, which is basically a promotion of this meetup's competitors. So sorry about that, Jeroen, but I know you love them. So who here has ever been to the Domcode meetups, also here in Utrecht? I think about half of them. So for those of you who have been there will know that they always start their meetups with this remark about how they absolutely do not tolerate any harassments over sexual orientation, gender, favorite programming languages, Vim versus Emacs, steps versus spaces, PHP versus everything else, you name it. And I love that they do that, because it's funny, but they also bring up an important message. But the reason that it's funny is because it's taking this jab at this stereotype about us engineers. And the stereotype is basically, oh boy. It's such a stereotype, someone printed it on a t-shirt, and the stereotype is arguing with an engineer is like wrestling a pig in mud. Sooner or later, you'll realize that the pig likes it. And you know, it's a stereotype, so it doesn't always hold, but it always holds, right? We love to argue, and if the sound works, I'm going to show you a short clip which is absolutely unrelated to this, or well, somewhat related to this remark, but otherwise not to the talk, but I just love it. So for those of you who have seen the TV series Silicon Valley, probably know what scene is coming, but the main character, his name is Richard. He's basically found his dream girl. She checks all the boxes. She's also an engineer, so at some point they're sitting on the couch, both working on their own projects, and then the following happens. Let's hope this works. That's Richard, man.
Richard, what's wrong?
Nothing. Nothing. Literally, it's all good. Come on.
Oh my god. Your roommates are right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision when you use spaces, but whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, practically. I guess I just don't understand why anyone uses spaces over tabs. Like, if it's all the same, why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes, all right? I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. Okay, you know what? I don't think this is gonna work. I'm so sorry. I mean, like, we're gonna bring kids into this world without over their heads. That's not really fair to them.
Kids, we haven't even slept together.
And guess what? It's never gonna happen now because there's no way I'm gonna be with someone who uses spaces over tabs.
Richard,
All right. I found it a very funny scene. But basically the point is we like to argue about trivial things like tabs versus spaces. I'm not going to take a position here, but I have one, of course. So this is a clear stereotype of engineers, but there's this other stereotype as well, which is basically when we come across a problem like this, we'll use technology to solve it. Like getting greasy fingers while coding. Right, so we have this problem of arguing over trivial things, and that's standing in the way of writing good code. So how can we solve this with technology? Well, that's how linters came into the game. So a linter is basically a piece of code, or a program. You give it your source code, and it will check, well, does this source code conform to some rules we define? So does it use tabs or spaces, whatever. And if it does, then it will exit successfully. Exit goes 0. Everything's great. Yippee, kumbaya. But if you violate those rules, then the linter will break your build, or it will halt your commit, and it will scream at you to fix your code right now. And this is great because then you can argue with your linter instead of with each other, and your linter is always going to win anyway. And today most people will use ESLint to use their code. How many people here have used ESLint on any of their projects? Okay, almost everyone I see. So it really clearly solves a problem for people. But ESLint is actually about the third generation of JavaScript linters. And the first one was written in a time when basically all web pages were bits of HTML, some CSS, most of it generated on the, sometimes dynamically generated on the back end with PHP, for example. And JavaScript was basically relegated to an on-click handler somewhere, or some fancy script that would follow your, that would draw a clock on your screen, that would follow your cursor, downloaded from shady websites such as this one. I don't know if some people recognize it. God help everyone around you when you use this. And basically nobody really took JavaScript seriously back then. But not so Douglas Crockford. And Douglas Crockford, he basically said, well, JavaScript actually, if you look at just a subset of the language, it actually has some fairly nice characteristics. He said, he even went as far to say JavaScript is more like a Lisp than Java or C, in that, for example, that functions are first-class citizens, so you can pass them around without executing them, and some other remarks he had. So if you just forget about big parts of the language and just use the subset, you actually have a pretty nice language. And he even, a couple of years later, in 2008, I believe, he even wrote a book on it. I would highly recommend it, where he basically took this point where he said, well, these are the parts of JavaScript you should use. It's called JavaScript the good part, and it's really not that big. It's the right one over there. Would highly recommend you to read it. But before he wrote that book, he wrote the first linter, ESLint, it was called. Sorry. And ESLint was, the first of its kind. Oh yeah, by the way, I'd like to insert some fun facts into my talk when I can. So your fun fact for today is that the name lint was actually derived from the undesirable, I have to check my notes, undesirable bits of fiber and fluff found in sheep's wool. And there's actually an entire Wikipedia page on this. So here's a picture from the page. This is lint, the little stuff. And this was not the first picture on the page, because apparently lint tends to gather in someone's navel. So the first picture was some guy's navel. I spared you that picture, so got that one going for you. Anyway, so ESLint was the first one, but and the concept resonated with people, but ESLint was very opinionated. Douglas Crockford has very strong opinions. He's also the inventor of JSON, and he has very strong opinions on not adding comments to JSON. So if you're ever annoyed that you can't do comments, he's the guy to blame. But people weren't weren't happy with the opinionatedness and not being able to define the rules that ESLint used, so they forked it, making ESHint, which was a fork of ESLint, and allowed you to configure your linting rules to some rules that the authors thought of. So you could say, well, we want to use tabs instead of spaces, or whichever one Crockford wanted, and other such stuff. So that was great, but you were limited by the rules that the authors of ESHint thought of for you. So that's when ESLint came to the scene, where, oh, you can write your own plugins, and you can do all kinds of weird stuff or normal stuff. You can write a plugin to have all your classes end with Smurf if you want, and you can add that to your rules. So that was great. But then people, of course, thought, well, you know, you have all these options, and this is so complicated, and everything is doing something different. So some people took ESLint, took some plugins, added some configuration to options, and named it Standard.js, which is very opinionated, has no options anymore. And hooray, now we're much better off than with ESLint, I guess. But this was somewhat of a digression. but Lint is basically, in my view, somewhat saved JavaScript. So everyone who's working on web standards has, or at least should have, the mantra, don't break the web. You can't introduce breaking standards to things that are used on the web, because there are websites out there that rely on them and it will never be updated. If you introduce a breaking change, those websites will simply break because no one's working on them anymore. So they couldn't really remove things from the JavaScript language. But when you use a linter, you can just say, well, we can add new things and then tell ourselves not to use the old stuff. And that's how we can actually have a somewhat modern programming language. So, for example, the TC39, the community behind JavaScript, could introduce let and const, and we can just add a linting rule saying, hey, never use var anymore, and everything's great. So that allowed us to progress in JavaScript. But I think the main function of linters is to catch bugs for you. So I'm going to have a nice exercise for you. So here's this is a screenshot of a demo app I will show in a bit. Yeah, I'm going to show the code. I could ask you what it does, but it's best for me to explain, I guess. So what I want to happen is I want to write some text in this text field, and I want that to show up here. And when I click the button, I want the font to blow up. And I've got some code to do that. And obviously, my question for you will be, what will happen when I run that code? So this is the code. So we have this input element, we have this paragraph where the text should be displayed, and this button to make it big. I add an event listener to the input element, and when you type something, I update the content of this text element. And when you click the button, I add an event listener for clicking it, and I will increase the font size of this text element. So who can tell me what will go wrong here? And I would say there are no wrong answers, but obviously there are. But it's okay to have a wrong answer, because I was able to think about it very long, and you didn't. So don't be shy. Who can see what will go wrong here?
Text is undefined.
So I will get a runtime error saying,
something like style is not defined on undefined.
all right. Anyone agrees with this or has a different opinion? I'll take that as you all agree or are too shy to say anything, which is okay. So let's give this a try. So first let's see if typing things here will work. Well, that appears to work fine. I'll open the console so you can see the errors. Let's click this button. Oh, sorry. I'm going to increase the font size by pressing the button. So I click this. The input element grew. How did that happen, you will ask? Well, there's a fun fact. So in HTML, and never ever rely on this, it's good that you don't know this because you're never going to need it anyway, but every element that has an ID will also spawn a global variable with that name. So there is a text element that I will be here assigning to. But basically the problem was indeed that so I define a constant here, which is in this scope, and not in this scope, so I can't access it here. So that's basically the problem. And there's a fun fact that it will then increase that font size. But let's see what happens. Oh wait, this one. When we insert this code into ESLint. And so ESLint will actually tell us, hey, you know, you're assigning here to a variable that is that you did not define in this scope, and you should do that. So it actually prevented a bug for us here. And if you have your editor properly set up, which most of them do nowadays, it'll do this automatically for you. So while you're typing, you'll see this red squiggly line, and you're like, oh, okay, sure, I have to add const text is whatever, or you know, work around this anyway, and you hardly even notice that it's actually preventing this bug for you and actually preventing this whole cycle of going to your browser, clicking it, and then noticing that it does the wrong thing, or even worse, not noticing, shipping it to the user, and then at some point hopefully hearing about this, or just users being really annoyed. So that's the most important feature of a linter for me, is that it prevents you from inserting bugs. But of course, it doesn't catch all bugs. Where are we now? Oh yeah, right, so I have another demo for you. So what I want this to do is you enter your age in this number field, and then it will tell you, hey, this is how old you'll be in 10 years, because you're probably not smart enough to think of that yourself, I guess. So I had the code for that here, I think. So, and this one is less of a trick question than the previous one, so, but obviously you're now all scared to say something. So we have the input, which is a number, and in this I element, I want to display the age in 10 years. So we have the age input properly scoped. So with the age input, which is that one, with the future age, which is this I element, we add a change event listener to the input. And when it's called, we'll take its value and then calculate the future age. So in 10 years, this is how old you'll be. And insert that into the I. What do you think will go wrong here? Who can tell? Yeah?
The input age variable is a string and not a number.
So what will happen?
You get 1010, I think.
Yeah, if your age is 10, you get 1,000, and your future age will be 1,010. Well, very well. Let's give it a try. Or did I have that? Oh, I should have opened that tab somewhere. Oh yeah, I have it over here. Can I just show this one? So let's give it a try. I am 12 here. So, oh wait, sorry. So it is a change handler, so this is not good. Oh man. Yeah, I even fooled myself. This is next level. Well, you know, just assume that it should indeed concatenate the two. So over here, current age, or this age input with value, it's an input element, so its value is a string. When you use the plus operator on a string, it will actually concatenate whatever is after it. So this 10, it's a number, but it will transform that into a string because the left part of the plus is a string, and it will push them together instead of adding them to each other. And let's see what happens if we insert this code into ESLint. So ESLint helps us catch bugs, right? Is this visible? No errors, damn it. So this is annoying, but now let's see what happens when we enter this into TypeScript. I've already done this in advance. There. So you already see, hey, I'd like you to define a type here. This is because I've set TypeScript to be really strict, which is the best way to run TypeScript. So let's add, okay, the playground the online playground is not great, apparently. So let's add a type annotation here. So I'm expecting a number here. Well, all right, if you want a number, you can't do this because this is a string. So convert it to a string, to a number. And then you're great, but then, of course, this will return a number, so we have to add to string here. That's actually not necessary because JavaScript... I should have. Did I forget a bracket? Yeah. Right. So now we're great, and this code works. So this is an example of how TypeScript actually helps us catch bugs. But there are a couple of things that are important here, and I've somewhat with my finger wiped out all my notes, so I hope I can reproduce them all. But the first thing to note is that when this code was problematic, right now, TypeScript, it said, hey, there's something wrong with your code, or I need this annotation, or whatever. But it did just produce the JavaScript output. So the experience there is very much like a linter. You can just run your code, and this actually is just JavaScript, right? So when you run TypeScript over JavaScript, you're not actually affecting the output in this case. Since it's just JavaScript, it can just take it in and push it out again. So it acts pretty much like a linter. So JavaScript is valid TypeScript. And this is an important point because some people think, oh yeah, TypeScript, new language, or no, we're going to invest all this time and effort into it, and then in a couple of years, it'll be like CoffeeScript, which was this other programming language, which was basically JavaScript with prettier syntax. And then I don't know if anyone here still has a CoffeeScript code base somewhere. Are you happy with your CoffeeScript code base?
Totally, I love it.
Oh, you love it?
Yeah.
Well, that's not. Yeah, I'll talk to you after behind the bicycle shed, maybe. Then. No,
It's awesome.
yeah. So the thing with the CoffeeScript code base is you have it right now, and nobody's basically used the code base to CoffeeScript anymore because most of the nice things about CoffeeScript are now in JavaScript proper, and people have that same fear with TypeScript that will happen there. But basically, TypeScript is JavaScript with some funky annotations. So when I added this number annotation here, look what happened to the compiled output. Nothing. It just strips it away. And it's very similar to JavaScript at this point. Parse in, this is just valid JavaScript, right, what I'm doing here. So all I added that's not JavaScript is this single thing. And the output is practically JavaScript. Obviously, TypeScript can also do, just like Babel, compiled back to, so if you're using, so it can compile this to an old JavaScript function to make sure that that it works everywhere. But in theory, it's just a very thin layer over JavaScript. And the intent of the TypeScript theme is really to keep TypeScript to support JavaScript features and to make to allow you to write JavaScript as you normally did, but with the added warnings that the compiler will give you, just like a linter did. Also look at how much TypeScript could already infer without even the type annotations. So it already knew that this input age was a string, because it knows, hey, we have here, and we use getElements by tag name. We find an input element has this value property. It already knows that, so it detected that this is an HTML input element. It has this value property. That means that this is a string. And that's great. So TypeScript can do a lot of inferral for you. And actually, when you're using VS Code, for example, on regular JavaScript, you're getting a lot of type hints. And behind the scenes, that's TypeScript doing that for you. So, all that is to say, TypeScript is not that big of a layer on top of your JavaScript code. It's some annotations to help you, or to help the compiler help you. But essentially, it's JavaScript, and you program in the same way you do JavaScript. So obviously, where's the catch? There's a catch, because this is additional tooling. So if you do not use any tooling at all, if you do not use a linter at all, for example, adding this or having to run something through TypeScript before running it is an extra step. That's a hassle. The complexity, obviously, I should turn off my email notifications. The complexity obviously is, so it's more things to keep in mind. So that's the main catch. But, well, not really, but because it's a serious thing that people should keep in mind. But it's not as big a thing as it used to be anymore because this happened. This is somewhere last year, Babel added TypeScript support. And what does that mean? Does it mean that Babel is now practically TypeScript and we'll have to keep up and we're having the risk of the two implementations diverging? No, that's not what's happening. So this was actually added by a contributor from Microsoft, and Microsoft themselves. So Microsoft are the creators of TypeScript, and they're actually working to maintain this this feature of Babel. It's actually a transform, as they call it, I think, which basically tells Babel how to remove the type annotations from your JavaScript. So it doesn't do type checking. It doesn't check whether your types are valid and will warn you. So, but it does mean that if you give TypeScript to Babel, then it will be able to read that. Whereas before this, it would crash. It would say, "Hey, what is this weird colon you have here in your function arguments?" Now it will strip it and then run it through the regular Babel compiler. So what this means is that you can, if you're using Babel, you can keep your existing pipeline, and your code output will not change at all. You can just, if you add a type annotation, enable this, what is it called? This transform, and it will look exactly the same as it did before. It's still Babel doing all the things, but you can run TypeScript in addition to it and separately from it, just like you would ESLint, for example, to warn you about potential problems in your code. So that greatly lowered the barrier of entry, and this also meant that, for example, in React, the primary way to run React applications is through create React app, which is basically this pre-configured Webpack setup. And they could add, once this was released, they could add support for TypeScript in their tooling without breaking compatibility with all the other plugins they were loading and the CSS support and whatever, because TypeScript was only on top of what they already are, next to what they already had. So right now the status of the ecosystem of TypeScript is very good. So most big frameworks, Vue version 3 is being rewritten in TypeScript. Angular has had TypeScript support for forever. React has now makes it very easy to get started with TypeScript. And the authors of every major library that does not have TypeScript support will tell you that the most common feature request they will get is to add support for TypeScript. Because for libraries, even if you yourself are not using TypeScript, it's very useful if libraries use TypeScript, because that means that your editor will be able to give you completions, will tell you if you're passing the library methods values that it does not expect. So the library support is also very good for the common libraries. And when the libraries themselves don't support it, there's usually a community member that is very good at keeping the third-party typings up to date. So that means you can now run, you can, for example, if you use React, for example, if you use React, so usually you do npm install React, and now you also do npm install add types/React, and TypeScript will understand what types React expects. And these are maintained by the community, and these are very well maintained. So if you use a relatively common library, you'll be in a good position to try to use it when you use TypeScript. So that brings me to when is a good idea to, if you're not using TypeScript yet, to give it a shot. So there are three circumstances, I think there are three things that make for an ideal circumstances. The first is if you already have a build pipeline or you're planning to use one, so you're running automatic ESLint checks, for example, or you're already running your code through Babel, then the step to add TypeScript on top of that is very low. If you don't use weird obscure libraries that nobody builds the type definitions for, which I would recommend against anyway, because if nobody else is using it, well, you know, the support story is always a bit iffy, unless it's a really small one, but then adding the typings yourself is also very easy. And when you're writing new code. So a lot of people in the will say that, you know, it's easy to migrate to TypeScript and incrementally over a JavaScript code base, and it is. But it's far easier if you already have some feel with, you know, TypeScript error messages can be hard to parse if you're just encountering for the first time. So on a clean code base, it's usually a good way to get your feet wet. People will also say that TypeScript is primarily useful at a large code base, which I would also argue against, because especially in a small or in a beginning code base when you're still figuring out what is the best API, what's the best way to do things, being able to quickly change something and have TypeScript tell you, well, then you need to also update something over here and over here and over here is very useful. And the setup is practically zero nowadays. So if you run, for example, a React app, usually you run create React app, your app name, and go. Now you run create React app, your app name, -- TypeScript, and go. And then you can just get started. So the setup is really low nowadays. I think. Aha. So in advance, Jeroen said, well, people always think, oh, it's a little bit short, and everybody thinks that, but in practice it will take very long. But this was it. So, aha. Unless you all have more than 50 minutes of questions. But you can also always tweet them at me if you want. But yeah, any questions? You had a question?
Yeah, so the first thing, you also wrote a blog post, I think, about converting a project in a React application I saw, so that was, thank you for that.
Mm-hmm.
So there's also, I saw the mention of Flow. Is there still a use case for Flow, or is it only, should you only use TypeScript?
Well, I would definitely not use them together.
Explain what Flow is for.
So yeah, so Flow is basically Flow has the same goal. Well, yeah, somewhat the same goal as TypeScript. They have some differences in nuances. And a couple of 1-2 years ago, it might be like, okay, with these two projects, which are we going to go by? And at this point, so the TypeScript team released an update, I think every 2 months, 3 months. Have been growing very quickly, and right now you see that the TypeScript is basically one, in the sense that, so if you use Flow, you also need the definitions of what do the typings look like for this third-party libraries, and it's far less extensive. Tooling support, React has good support, because Flow is also by Facebook, but otherwise, so for other projects, it's not as well supported. It's also written in OCaml, I believe, so it has less third-party contributors. So yeah, so you would choose either Flow or TypeScript. Probably both are. So the goal of either is great, but TypeScript is the more well-supported one. So the community buy-in is the biggest advantage that TypeScript has. So yeah.
Thanks.
I was wondering, you used to have ESLint as well, and that's now you're supposed to use ESLint again because they've merged them.
Right.
Do you have any idea what the benefit will be using that also next to TypeScript?
TSLint or ESLint?
ESLint nowadays, I guess.
So there are, well, TypeScript will never, for example, tell you to use tabs or spaces. So you have the styling or the code conventions to keep your code consistent if you have a serious problem with that. And there just are some errors that, well, yeah, it would actually be interesting to take a look at which rules ESLint has that are already caught by TypeScript. There will be a lot of them, but also, I guess, a lot of them that might be out of scope for TypeScript because they're technically valid JavaScript, but not a clean pattern to use.
TSLint still teaches me to close my promises correctly.
Right. Well,
which I find very tricky.
Yeah.
Trading commas. Woo-hoo.
Trading commas. Yeah. So yeah, for example, yeah.
Yeah. So styling, code conventions, and
Yeah, but still some bugs, right? Or potential bugs that make your code unclear, or that make it easy to introduce bugs to your code, but are technically valid. TypeScript will not warn you of things that are just valid JavaScript, and ESLint will, I guess. So, but in the case of ESLint, it's basically the same story. So what React does, or what Create React app does, what I really like is they have enabled ESLint, but only the rules that help you catch bugs, and not that they don't enforce tabs versus spaces or whatever, which is great because then you don't have the setup cost of having to define your own ESLint configuration, but you're also not going to be annoyed by, oh, I have to fix this random issue again because they want me to use tabs, even though it's just your habit or something. So yeah, you can definitely still use them together. Yeah?
Do you also use Prettier?
Yeah, you can. So Prettier has TypeScript support. I personally haven't used it yet because I don't like, because I have projects that I've started before Prettier, and I don't like having one commit that touches everything and then pollutes my history. And I don't have so formatting inconsistency are not a big issue for me. So I have some colleagues who do some things differently, but I can still perfectly fine read their code. They can read mine. But you can use it together with TypeScript. So that's another point. So that tooling support or the ecosystem support for TypeScript is very good right now. And I think as soon as Prettier was released, the number one issue was, oh, I want TypeScript support. And a community member jumped and added TypeScript support. So, and this was, I don't know, how old is Prettier now? 2 years or something like that. So that would nowadays would be even, like you can practically assume that most tools will support TypeScript or work well with TypeScript.
One more question? Yeah, and then you talked about CoffeeScript becoming obsolete. Sorry. That's interesting. And I was wondering, I remember TypeScript being explained to me as like JavaScript with strong typings, but also with like it's the JavaScript of the future. It has all the ECMAScript features already running in it. Do you think that JavaScript will catch up, and then TypeScript will just be only JavaScript with strong typings? And then is it a means to an end, or will it always?
So the question is basically, will TypeScript shape JavaScript's future, I guess, right?
Yeah, I guess.
So TypeScript is not that, so will JavaScript catch up, and will TypeScript basically be JavaScript with strong types? That's already basically what TypeScript is. So TypeScript doesn't, so when new features land in JavaScript, they go through 4 stages. So first stage is someone proposes it. Second stage, I think, is there has been community input or something. Then third stage is there are 2 different implementations. And then the fourth stage is, well, next version of JavaScript we will release, this will be in there. So I think from the third stage on, there are practically no more changes to a new proposed change to the language or addition to the language. And only at that point does TypeScript implement it. So TypeScript doesn't usually implement their own non-standard JavaScript things, unless it's type annotations. One exception there is, so you have the decorators in Angular, but those are, you have to explicitly enable that in your configuration flag. So they basically added that because the Angular team strong-armed them into doing it. Which is going to bite them now, because so you have the experimental decorators flag, I think, so that already should tell you, well, it's experimental. And the way JavaScript is implementing them right now, I think, is subtly different, so that will probably be a breaking change for those who do have enabled that flag. I'm not, I don't really use Angular anymore, so I'm not too up to date with that, but I believe that will become a problem for them. But in general, the idea behind TypeScript is, if JavaScript evolves, this shouldn't cause a problem for TypeScript. So the question is, will JavaScript add type annotations? And I think the main benefit of TypeScript is for catching errors while you're programming. So you run the TypeScript compiler over your code and it will tell you, hey, here's a potential bug. So if JavaScript were to add typings, the only thing it could do is add those type errors while your code is running in the browser, which is in my view, too late. So I don't think there's much pressure for adding it to JavaScript. There's also, JavaScript has some bit of history where, so you had ES3, version 3 of the language, and then you had ES5, version 5, and now they do yearly releases, so they label with the year. And there has been an ES4 proposal, which was basically JavaScript with types, and this was a corporate political hellhole, and nobody, people have traumas over that, I think. So I wouldn't expect that to happen anytime soon. And if that were to happen, so the TypeScript and Flow type annotations are very similar, and they are also both based on this proposal from back then. So if that were to happen, it would probably be similar to what TypeScript does. Although then the question will be, so if TypeScript already checks your types, what runtime information do you still need? So maybe it would still strip it anyway. Or it could do, I think, what Python is doing, is adding syntax for, hey, this is what type annotations should look like, but we're not going to do anything with it, but third-party tools can, which would basically be working together with TypeScript and Flow, presumably, to standardize that. So yeah, it's basically JavaScript with types.
There's also, can I just jump in?
If you don't allow it.
Okay.
Really quick, please.
Yeah, very quick. That's also one of the issues, of course, with TypeScript, that it will never be able to innovate any faster than JavaScript is innovating, in the sense that there are some things that it will just never do. Like, for instance, there's this Elvis operator that everybody wants, right? If you have like a foo.bar.bas reference, you want to basically be able to say that, well, if foo.bar is undefined, then basically the entire thing should return undefined, for instance. That is a thing that they will never support
3.7.
unless JavaScript is going.
It made stage 3 now.
For JavaScript, you mean?
Yeah, so TypeScript
so
now
it
will.
basically means that TypeScript is in a way limited in what it will ever be able to do because of what JavaScript is able to is going to be able to pull off.
Flow will complain a lot about.
What's that?
Something Flow will complain a lot about.
Right. Yeah.
Query selectors.
Which, of course, is why CoffeeScript is so much better, because CoffeeScript has.
All right. Thank you.